up, everybody? Alright, today we're going to be talking about quantum numbers. Alright, so yeah, if you're new to this YouTube channel, I basically put out some chemistry videos kind of explaining a topic to my best abilities, and I also provide a free note sheet with each module. So if you'd like to print those out in color or just like have them on your computer or other screen to add on to what I'm saying, that would be helpful. Okay, these are the notes. Okay, first things first, let's talk about principal quantum number. This is classified as n. And so we can have n equals 1, 2, 3, 4, and so on. This defines relative distance from nucleus and energy of the electron. So farther out, we're going to have a more unstable orbital. Okay. Now, we have an energy of an electron in hydrogen, and so it's the energy of the one in hydrogen is En equals negative RH times 1 divided by n squared. As I said, the En is going to be the energy of one electron, and the RH you see is actually the Rydberg constant for hydrogen only, and it's 2.18 times 10 to the negative 18 joules. But do note that when E equals 0, this means the electron has been disconnected from the atom and it's not moving anymore. Next is the angular momentum quantum number. L equals 0, 1, or n minus 1 to simplify things. And this tells us the shape of the orbital, aka it defines our subshell. Now, throughout this unit, subshells and orbitals, you don't want to get them mixed up because then you're going to be giving the location of an electron possibly somewhere else. So be careful with what with your wording. So all electrons with the same value of n and L are said to be in the same subshell. Keep that in mind. I created an L table, that's what I like to call it. It gives the values of L and the name of the subshell it's in. So for example, L value of 0 would be a S subshell, 1 would be P, 2 D, 3 F, 4 G, and I have a way to remember it. It's Sam, Pat, Fred's goat. Notice that it's S, P, F, G, so the first letters of those. Okay. So, our first question. In the shell, n equals 4, what are the names of the subshells it has? Ready? Okay. So the answer is actually 4 possibilities. You can have 4S, 4P, 4D, and 4F. Or 4F, excuse me. So we know that n equals 4. Fourth, okay. So L equals 3 because it's the 4 minus 1 from that equation we got, expression we got earlier in the slide. And so we look at our L table and we notice that since L equals 3, this encompasses the S, P, D, and F subshell. So it encompasses all above as well. So you have 4S, 4P, 4D, and 4F. So next we're going to talk about the magnetic quantum number, M sub L. M sub L is negative L all the way to positive L, and this gives us our orientation of the orbital. It gives the number of orientations as well, and all electrons with the same N, L, and M sub L are said to be in the same orbital. So now we're not in the same subshells, we're in the same orbital. So we're getting a bit more precise with our locating our electrons now. So other notes to know, put in brackets here. N, L, and M is kind of where the electron lives, it resides. So N, L, M, not living Montana, that's kind of another way to remember it. N, L, M is the first letters of that phrase. Okay, yeah, that's it for this quantum numbers, but I'm going to have much more practice coming up. Just stay tuned for that. If you have any questions so far, just email me. I'm also going to link it in the description. Subscribe, follow, don't forget to do that. My Instagram is also going to be in the description, so if you guys want to see some more note-taking, some other things like that, be sure to follow me and subscribe. And yeah, that's it for this video. Peace.